Hello everyone. Today I'll talk about nuclear magnetic resonance spectroscopy. There are two kinds of nuclear magnetic resonance spectroscopy. One is HNMR, another one is CNMR. So today my topic will be only HNMR, hydrogen nuclear magnetic resonance spectroscopy. So HNMR, when you talk about HNMR, basically you have to deal with hydrogen. So if I give you any particular compound, you have to do the HNMR. So I'll give you one example and I'll explain how you can figure out HNMR and everything, okay? So for example, if I give you this one. Okay, for example, if I give you this particular compound and if I tell you find out the HNMR, how you can figure out the HNMR, it is really simple. How you can figure out the HNMR? You have to figure out that how many different hydrogen in there. How many different hydrogen means how many different environment. So can you first tell me what is the name of this one? The name of this one, if you see, there is in the middle there is a double bond O, that means it's a ketone. And what is the name of this ketone? 1, 2, 3. So look right now, if you start count from this side, why you want to start counting from this side? Because this carbon has a one substitute in there. And why you are not counting the benzene as your functional group? Why not? Because the double bond O is my functional group, so that's why this is number 1, this is 2, and this is 3. And why not this carbon is number 1? Because this carbon has not any substitute present in there, but this carbon has a substitute present. So that's why this carbon is number 1. So what is the name of this one? That number 1 carbon, you have a phenyl. And number 2 position, second position, you have a ketone. So what's the name of this one? 1, 2, 3, propanone. This is the IPF name. This is the IPF name. Okay. So this example, first what you can do, because first you can find out the different environment. What is the first things you can do? Find out the environment. So if you want to find out the environment, draw this one as a what is called structure formula. So structure formula, if you want to draw, just draw your hydrogen. Okay, this is your hydrogen. Okay, then you have to find out the environment. How many different environment in there? So for example, look right now, this hydrogen is really different from any other hydrogen. If we circle this one, that means you don't have to count this one. This one and this one is the same thing. These two is the same thing of this one. Okay, so we find out the one in this environment is totally different from any other hydrogen. Totally different environment. So this is environment number 1. It doesn't matter that what is the number of this one is environment number 1, 2, anything. You can start from here or there, anywhere. Okay. Then look right now. This hydrogen is also another different environment. How? Because this hydrogen carbon is one kind of hand, and then double bond O, then benzene ring. So that's why if you compare to this one and this one is totally different, because why? This is CH2 hydrogen and this is CH3 hydrogen. This is CH2 hydrogen, this is CH3. That's why this is totally different environment. Okay, come to this one, benzene ring. In the benzene ring, and also in the benzene ring, look what happened. In the benzene ring, book says that some books say that this is only one environment, this 5 hydrogen the same thing, that's why this is one environment. But basically this is not true. Why? Because there is just little bit difference. Book mention all hydrogen in there is a one environment. Because why? The reason is the differences between all the delta values is really little. So that's why they say all the environment, all the hydrogen environment in there is a one. But this is not true, because little bit difference means difference. Any kind of difference is a difference. So look right now. Okay, this hydrogen and this hydrogen is the same thing. So that's why count this one is a environment number 3. This is your environment number. This one and this hydrogen is a same kind of environment. So they say this is 4 and this is 5. Okay, so right now you find out your environment. How many environment you find out? You find out how many environment? 1, 2, 3, 4, 5. You find out 5 environment. So you find out environment number 1, environment number 2, environment number 3, environment number 4, and environment number 5. So for environment number 1, this hydrogen, you have to find out the multiplicity. What you have to find out? Multiplicity. So how you can find out the multiplicity is really simple. How? Because multiplicity rules is number of adjacent carbon hydrogen. Number of adjacent carbon hydrogen plus 1. So for this hydrogen, which is the for this hydrogen, carbon is adjacent carbon is connected with how many carbon? Connected with only one carbon. And this carbon has a how many hydrogen? This carbon has a no hydrogen. That's why this is 0 hydrogen plus our formula is a 1. This is 1 multiplicity. So I told you hydrogen, number of adjacent carbon hydrogen. Okay, so that's why this carbon is connected with this how many carbon, and those carbon is a how many hydrogen. This 1 plus formula is a 1, and this is going to be your multiplicity. For example, this hydrogen carbon, this carbon is connected with 2 carbon. Which 2 carbon? This carbon and this carbon. So this carbon and this carbon has a no multiplicity. This carbon, no hydrogen, sorry. This carbon and this carbon has a no hydrogen. So that's why this is also 0 hydrogen plus formula is a 1. That's why this is 1. Right now, number 3. So environment number 1 multiplicity is what? 1. Environment number 2 multiplicity is 2. Right now environment number 3. Environment number 3 is this hydrogen is connected with this carbon, this hydrogen carbon. Hydrogen carbon is connected with how many carbon? 2 carbon. This carbon and this carbon. This carbon is a how many hydrogen? 1 hydrogen, and this carbon is a no hydrogen. So that's why this is 1 plus 1 is equal to 2 multiplicity. Go to the next one. This carbon, this hydrogen, number 4. Number 4, this hydrogen is hydrogen carbon. This hydrogen carbon is connected with how many carbon? 2 carbon. This carbon and that carbon. This carbon is a 1 hydrogen, that carbon is a 1 hydrogen. So that's why 1 plus 1 is equal to 2, and our formula is a 1, so that's why it's 3. So we find out number third environment multiplicity is 2, and fourth one multiplicity is 3. Go to the fifth one. Fifth one, this hydrogen carbon is connected with 2 carbon, and this 2 carbon has a this carbon has a 1 hydrogen, this carbon has a 1 hydrogen. So 2 plus 1 is equal 3. This is your multiplicity. This is your multiplicity. This is your multiplicity for different environment. Right now, and one more thing, if you want to find out the multiplicity, don't count them. Because why? This hydrogen, this hydrogen, this hydrogen, the same thing. So this hydrogen, this hydrogen, this hydrogen, the same thing. They are think as like a brother, and you cannot count the brother. You can count the this is your father. This is you. Think like that. How you can be figure out the multiplicity is very simple. I make a very easy formula. How? This hydrogen think as like a you, and this is your parents. Parents will like think as like a father. Then your father has a how many brother? Your father can be brother 1, 2, 3, whatever. And then your father brother is your uncle, and your uncle's son and daughter, you're gonna be count. Do you understand? Okay. This hydrogen, for example, go to the next one, this one. This hydrogen is you. This is your father, and your father has a 2 brother, and this is your uncle. This uncle has no son or daughter. This uncle has a no son and daughter. That means what? 0. And your formula is a 1. So that's why this is how many multiplicity? 1 multiplicity. So do you understand my formula? I'll write it down clearly. You, then your father has a how many brother and sister? That means your uncle or aunt. Your uncle son and daughter, son or daughter, you will count, and formula 1. Then you will not make a mistake in your life. And some student, they count them too, but this is wrong. Why? This 2 hydrogen is your brother, and you cannot count your brother. That's it. Then very easy things is right now you have to figure out the what? Delta value. If you want to find out the delta value, how you can figure out? You can get your delta value is from here. This is the chart I get from the books, and if you use this chart, you can figure out your delta value. How? Look right now. This is your benzene CH3. So look right now. This is your CH3 is this one. So its value is like a delta value is approximately 0.9 to 1.8. But 0.9 to 1.8, but you cannot give 0.9 this one. Why? Because the electronegativity of oxygen and carbon is little bit higher. So give this one is approximate. You can give anything like delta value environment number 1. Think like a delta value is think like a 0. Give 1. 1.1. Give 1.1. And you can give anything like 1.3, 1.2. It's up to you, because there is approximate 0.9 to 1.8. Go to the next one. This one. This one is delta value is little bit higher. How? Go to the next one. This is your. It would be your. This one again. Give this one is delta 1.5. And environment number 3. Environment number 3 is this one. This one is a delta value is go to the your benzene ring one. Benzene ring, this one aryl means benzene ring hydrogen is 6.52. Benzene ring is 6.5 to 8.5. So this one is going to be highest one. Why this one is a highest one? Because the reason is This one is highest one because look, this one is electronegativity of everything, this side and this side. You see, that's why this is electronegative. Because why? Because the oxygen in there little bit closer than this one. This hydrogen electronegativity of oxygen, all other things is little bit closer. That's why is higher electronegativity. That's why this one is going to be get 8.5. Then think about this one. This one is going to be get like a give 7. Delta value is give 7.0. And number 5, it's going to be lowest one because it's too far from everything. So that's why this is 6.5. This one is what? 6.5. This is your delta value you figure out. Right now is the interesting part. You have to find out the what? You have to find out your draw the what is called I forgot. 1 second. This is basically okay. Right now you have to draw the spectrum. What you have to do? Draw spectrum. Right now you find out your delta value, and from where I get the delta value? From the table. You can get from the internet also, or from your books. This is the table. You can get your delta value. If you find out your delta value, then what you can do? You can draw the spectrum. And spectrum is really important. How it's important, I'll show you how you can draw the spectrum. So look right now. Okay. So how many environment in there? There is a 5 environment. Okay. So it start from, and the delta value is 0 to 8.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, and this is your 9. Okay, and this is 1. Okay, so look right now. You have given the multiplicity. Multiplicity 1 is called singlet, 2 is called doublet, 3 is called triplet. If it is 4, it is called quarterlet. It 5 called pentlet or hex, whatever. Singlet, doublet, triplet, quarterlet, something. Okay, then you can figure out your what is called the spectrum. You can draw the picture how is going to be your peak. Always remember your 0 is going to be the small peak like that. Okay, and then go to the 1.1. So 1.1 is going to be where? In there. Then you have a 1.5. 1.5 is in here. Okay, 1.5 is in here. Then you have a 8.5. 8.5 is in here. Then you have a 6.5. 6.5 is in here. Then you have a 7 point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, we got it. right now is the, okay, look right now, this is called upfield, this side upfield, and this is called downfield. This is called upfield, this side is called upfield, this side is called is downfield. So what is the things right now is the upfield delta value is lower, downfield delta value is higher. Higher delta value means higher electronegativity, and lower delta value means lower electronegativity. So right now, look right now, this is called downfield, this is called upfield. Upfield has a lower delta value, downfield has a higher delta value, and we figure out where is going to be our peak. So come right now is in this one, 1.1. Go to the 1.1, and 1.1 is a how many multiplicity? 1. Why you need a multiplicity? Because of multiplicity you can say how many peak is going to be there, and this one is 1.1 has a one singlet multiplicity, that's why it's going to be how many peak? 1 peak. So 1 peak means this is your singlet. Okay, this is your multiplicity of this one, peak. Then go to the second one is this one. This one is a 1.5. Go to the 1.5. 1.5 is a how many? How many? Oh, no. This is, sorry, it's singlet. This is singlet. Why? Because this hydrogen carbon is connected with 2 carbon, this carbon and that carbon. This 2 carbon has no hydrogen. That's why this is what? This is singlet. 0 plus 1. This is 0. Multiplicity is 0 plus 1 is equal to 1. Okay. So this is also singlet, but this is called bar. This is called what? Bar. Right now, always remember, if there is no benzene ring, that means if there is a no benzene ring, CH3 is going to be the highest, tallest bar. So this one is going to be the little bit lower than CH3 and 1 peak. Then go to 6.5. Okay. 6.5 is this one. 6.5 is delta value is 6.5. How many multiplicity? Is 3 multiplicity. That's why it's going to be 3 peak. One thing you have to remember, if there is a benzene ring bar is the tallest bar. Benzene ring bar is the tallest bar. Then second is CH3, then it comes like that. But there is no benzene ring, that means CH3 is going to be the tallest bar. So go to the next one is 7 point. 7 point is your also 3 peak, but it's the same height because it's if this is in the benzene ring. So height is going to be the same, and 3 peak. 8.5 is also in benzene ring, that's why the same height. And this is your spectrum. I'm not good in drawing, so that's why it's not that much good, but it's okay. You understand how you can draw the picture and all those things. And the 0, you have a very small peak. Then we figure out how you can do that. Your spectrum, you can draw this one. The main important things is find out the environment. If you find out the environment, then you can find out the multiplicity. Then first is what? Environment. Then is multiplicity. Your environment multiplicity. Then you can find out your delta value. Apply the delta value in the spectrum. Apply the delta value in the spectrum. That's it. How you can multiplicity is the number of adjacent carbon hydrogen plus 1. This is your formula for find out the multiplicity. And this is the HNMR. I hope you guys like my video. If you like it, don't forget to share with your friend, and don't forget to subscribe. If you have any question, you can email me anytime. My email address is alamgirhussain1992@gmail.com. I'll try to answer your question as soon as possible, and study hard, and thank you for watching my videos. I hope see you in the next video.